and welcome to today's webinar, where we'll be taking a look at the potential for improving the energy performance of existing commercial buildings and how the technique of rapid energy modelling can be used to provide an understanding of a building energy use and help in the development of suitable retrofit solutions. My name is Kenneth, and I look after the Cities and Built Environment portfolio here at 2 Degrees. I'm delighted to welcome our presenter today, Oliver Riley, who is an associate of the Energy Services Division of URS Infrastructure and Environment in the UK. Oliver's presentation will last for around 25 minutes, which will give us 10 to 15 minutes for questions at the end. To begin, I'd just like to remind everyone that you can submit questions throughout the webinar using the Q&A box on the bottom right-hand side of the screen. Just type question and press send, and wait until the end before answering as many as we can. As noted, if you should have any technical issues during the presentation, please use the chat box on the right-hand side to send me a message, and I'll get back to you as soon as I can. So without delay, I'd like to hand over to Oliver, who will get us started with today's presentation. So over to you, Oliver.
You can hear me okay, and my eyes working. Let's see. We'll kick off. I'm O'Reilly. I work in the London Victoria of URS. If introduction, I won't linger on this, but URS are a internal multinational engineering services provider in the buildings and infrastructure in the UK. That comes under the infrastructure bullet point there on our globe as one of 4 key markets. And I work in a small team. We've got a headcount of about 25 called Sustainable Design and Construction. So I'm here today to talk to you about rapid energy modelling and to try to fit it into one sentence. It's a tool or a workflow that we use to identify and evaluate opportunities to improve buildings, basically. So to reduce the cost in use, the energy and operational cost, and improve the energy performance of a building in a nutshell. I would add that we strive to improve the quality of the building and the experience of using the building as well. So we'll come on to that in this presentation. So I've got about 20 slides to talk around today on rapid energy modelling. So I imagine it will take around 20 minutes, and forward to some discussion or question and answers afterwards. Why did we start looking at this rapid energy modelling? Where has the impetus come from? Well, this figure that we banded around a lot, I presented it a couple of weeks ago at Sustainability Live at the EC, and all the other presenters in my session quoted this statistic, which and we all quoted the same statistic, which so it wasn't. There was no embarrassment there, but as he by Pike identified that buildings are responsible for 40% of global energy demand. So a huge influence on the energy that we consume in the world. We're on a zero carbon timeline in the EU, at least, to building zero carbon new build by 2019. And we're seeing that implemented through building regs and through planning policies. So I'm going to crack the new build element, but that second statistic on there indicates 70% of the buildings that will be standing in 2050 are already here now. So we've got opportunity with existing ability really to those with the advances in technology and the advances in understanding of how buildings work. So let's drop to where we started doing this train of thought. And the of other drivers to change existing buildings, to improve them, and I indicated a few semi-commercial. We've got an uncertain, in terms of energy costs, we've seen great rises in the last 5-10 years in the cost of energy, and the issues in the future about security of supply. There's the kind of the fact that the environment has become much greater part of our as industry professionals, obviously, but as the public as well. So landlords and building owners a desire to improve buildings in order to be more environmentally friendly, and there's a lot of benefits and all sorts of things that come with that, but fairly strong these days. So, looking to improve a point on that slide. We've been in the commercial rental market, a big uptake in the desire to improve building offices in terms of lettability. So we've had the demand, I think, has been outstripping supply for offices through the downturn, and one of the differentiators in the rental market is how a building performs in terms of its environmental credentials. So that's just an interesting observation we've made over the last couple of years. So we do a process called rapid energy modelling, and it's primarily treat existing buildings, and I'll briefly describe it in 4 stages what we actually do. It's a process of capturing information about the building, modelling that they're using computational methods to simulate the energy performance of a building, and then using that information to advantage to help us identify areas to improve a building, prize areas to improve that building, and then we can go on to sort of simulate how the improvements will benefit a building and so on. So, in terms of what we actually do, we go to a building. That's imperative. So it's not a desk-based methodology. We actually go out there and we a building. So engineers, and we have the trained building surveyors and building auditors working in our ranks. And if you develop rapid energy modelling, we've been assessing buildings for many years and identifying areas to improve energy efficiency. So this is not a new sort of method that's come in and usurped all this before. Rather, it's a new tool to help us be more efficient. So building, perform a site survey. While we're there, we capture information about the geometry of the building and its characteristics into a computer model, as well as making the observations that as trained building auditors we would be made looking around, looking at systems and spotting opportunities to improve things. Information then does get taken back to the office through a simulation tool, which I'll come on to, and there lies the results that come out in order to help us on those opportunities. So, actually using this tool, well, it helps reduce the running cost and CO2 emissions of the building. That's the bottom line. But the tool itself provides a much more rapid focus on improvement options than could be done before. So we can be talking about days to make decisions on how to improve a building rather than weeks. It also creates a build, if you like, a building information model. So that 3D spatial model that's embedded with data can be used as a legacy tool. It can be retained, it can be improved, refined, and modified to other changes to the building, and use it as a management tool. I'll just to the building information modelling very briefly. I mentioned it there. It's an approach to to design, construction, and operation of it using a single set of computational model. So the idea is, instead of the client, the architect, the engineers, their own sets of information, their own drawings and so on, is that there's one which is developed at the outset of a project and then lives with the builder its lifetime. And existing buildings, BIM is usually in place. What we mean by bringing rapid modelling in as the first stage is that we are creating a BIM model of that building, which we could modify and use interchangeably. We view it other lenses, if you like, in the future to aiding management. So, what makes our process quicker than what we did before? Two key things, really. We gather the data about the building, and sort of streamlined approach to modelling. So, in terms of data gathering, what we want to do is hold of information to build a 3D model of the building, and a number of ways that we do that. So we need its geometry, and we understand about construction and materials and it's occupied and so on. So we do that from drawings if they're available. Sometimes we find that they're not. So we've developed a few other approaches. One is laser scanning. We have a dedicated laser scanning team, and they produce these very detailed high-resolution scans of them, which can be fed straight into the 3D software. So this one you can hear is our own head office in Basingstoke. So it was the first building we started looking at about 3 years ago, and that's a laser scan. Its approach is very accurate, but it will take around half a day, so it's not the absolute sort of fastest method we can use. With a tool called Photogrammetry, and that's something where we can get a bit of a economy advantage, because the 3D model simply from photos that a trained site engineer has taken when to visit the building to perform the audit. So we take a whole bunch of photographs around the building with software that generates a 3D model from those images. You see there. So we've used that with great success so far. We've also got a 3D sketching approach. Should drawings be available, this is very good. So key there is we can, with a minimum of information, generating the model and starting to look at the results very quickly. Once run the 3D model and run it through the energy simulation, a whole range of results. It gives headline results you'd imagine in terms of kilos per am of electricity usage, so the energy usage of the building, the conditions of the building, but it also shows things like seasonal breakdown of energy use. And so this part I'm showing on this slide is showing heat gain seasonally across the year. This is for the Basingstoke office that the slide just showed you. And just a quick comment as an aside, I can see questions coming in. I'm going to answer those at the end, if that's okay. This chart here shows the seasonal heat and come from different areas within the building. What you can see is the solar heat gain through the windows. So that's direct incoming sunlight, basically. It is a peak seasonal heat gain. It causes a considerable cooling requirement, which is expensive and intensive. Now, there was an issue. It's our building, and we knew, for instance, that people get hot if they sit near the windows in summer. And it's got a high glazing area, so we knew it was an issue. But this shows the solution bears out and shows us that it quantifies what the level of solar gain through the windows, and leads us then straight looking at glazing options, so sheen, solar film, different options to cut down those that solar gain. So it has to focus on decision making straight away. The energy model also allows us to perform sensitivity studies quickly. So this is the same model that we produced with it to simulate daylighting across the floor. So we're looking at a shading, an equal shading option. Two models shown there: the building as it is on the top left, and the build shading option on the bottom right. And the coloured cells on the floor indicate levels of daylighting. And what we could do before in the unimproved model was that we had some quite high levels of daylighting, basically glare and discomfort, and the glazing as the option has mitigated that. So at the quality of the environment in the building, so it's a quite flexible tool. I'll cut to the nub of it is what the output of this kind of study, a rapid energy modelling study, would give. And this is quite a key slide, so I'll just spend a couple of minutes discussing it. What you can see is that we've considered around about 25 options for this particular building. This is from another project that we did in Manchester. A large naturally ventilated office. And the 25 options are all specific improvement options that could be made to that building that come out of our site survey and our modelling work. So you see there, you've got things like adding the set points on the heating system, put lock on the water heaters. So these are to the building. Then you categorize them on a light system: green, amber, and red. Then what we've did from simulating each one of these opportunities in the rapid energy model as a list to assess the net specific cost per CO2 saved. So the energy model tells us the energy reduction which could be achieved by each one of these measures. We can use that the reduction in energy cost of energy for the building. We take into account the capital cost of making those changes, any impact on maintenance, and we use it to calculate the net specific cost, so whole life cost of making that change per ton of CO2. Essentially, when we display that on a chart, if it's per line, that means a negative cost of its actual value to you over its lifetime, and that could be 10 years or 15 years. So if it's per line, it's green, it's something that should be done. If it's a blue line, if it's amber, well, use those financial analysis criteria. It doesn't quite give a net present value, and so it's something that shouldn't be prioritised, but put on the back burner. We might look ways to improve the of that option, and we might bring it into play once the green items have been done. The items have a significant cost attached to them, but we shouldn't prioritise those. Those should be put to the top of the queue. Perhaps when in 5 years' time, when we've made all the other changes and the building is all in and all dancing, but we want it to be absolutely the best thing since sliced bread, we should look at the bread options. So that marginal abatement cost curve, and once we explain that, and you see the relationship there, then we find that a very effective way of communicating the purpose of these options. So essentially, what we're doing on this building in Manchester is we're taking that top 10, the items, and we're putting a plan together to implement those on the building. That's the result of the rapid energy model. It allowed us to focus on those performing options. So we to date, we've done this bit out of date now. We've actually done around 15 buildings, different buildings around Europe, mostly in the UK, but of all different types. When we form the model, we've then calibrated the results each time against the actual usage from build data. We find consistent accuracy within plus or minus 15%. Now, that's a lot. In the world of simulation, there are variables around weather, around occupants' habits, the way people use building, that it really is difficult to actually put your net to an accurate prediction than that. So we'll go a quick case study, and then we're coming on to a good time for questions and answers. So, building an office in central London that we've looked at. It's a lovely building, actually. It's listed. It's a big building. It's quite near St Paul's. It's tenanted, so each floor's a bit different, but that's the same on each floor, in that it's all office space apart from the ground floor, which is retail. And around 50 grand a year on any. That's the management company, and that we did the study for. It's been refurbished quite recently, so it's got a fairly modern VRF heating and cooling system. We went to site. We were there for around 3 hours. We used the photogrammetry technique. So just going that you see in the top right that looks kind of grainy and a bit strange, that's a photorealistic 3D model that we produced from straight images, no drawings. We didn't have any drawings of this building. We used to create the photogrammetry technique to create the geometry. We performed an energy model, and we've arrived at an accuracy for this particular one of less than 10% compared to last year's build data. It's all electric, this building, so in that pie chart you can see there, we show a breakdown of electricity consumption for the building. The chunk you can see there is miscellaneous equipment, but that includes all operations within the building essentially. So all the power, computing, print faxes, so on and so forth, and it's intensively serviced building. So you can see how that correlates to what you might expect, is that the biggest proportion of energy use is down to miscellaneous equipment. But lighting is the other big one, and you can see the building, it's overshaded on, it's heavily overshaded. I mean, it butts right up to other buildings on two of its faces, and the remaining face that's over the street elevation is north facing, and the glazing area, just going back and looking at it, the glazing area is very small, so it's got a low glazing ratio. So you would expect that actually daylighting opportunities are limited, and lighting is on most of the so the thing is a significant consumer. So from that rapid energy model, we identified again a series of improvement opportunities, and they're on the light system. So we quantified those in terms of estimated costings and whole life cost, and ranked them in order. So the green things, the things that they should do straight away, there's a whole list of good recommendations which I haven't scheduled out here because it's quite long, but are specific to the building that we've recommended, and it's behavioural change and things that can be done at very low cost or for free. So, for example, things like putting time clocks on things like monitors and so on, or implementing a regime of switching off monitors. That's a very boring one, and one that everyone's probably done a million times, but there are ones on there that are slightly more innovative than that. In terms of physical changes, there were two other things that we identified in low-cost quick wins. There was a control system issue, so there were two control systems weren't talking to each other, so we identified that by improving that control system, and we've written in the spec, the brief spec for exactly what needs to be done, they can have better control over their heating, ventilation and air conditioning systems, and bring down the operational cost there, and also some time clocks on water heaters. So they've got point water heaters that are on 24/7. So go into the medium cost and the longer term things, but the point here is that they've put there an implementation strategy, or rather we've done it for them, to get away on the green items, the low cost quick wins, and starting savings straight away, and perhaps they can recycle some of those savings into some of the medium and strategic term things. Anyway, look at a way to improve the building in terms of energy and carbon performance significantly. So here's just the bars are showing energy cost, and the dots in carbon emissions are directly related because energy cost is all electricity. Current building's not performing as well as the benchmark office of its so we're saying, based on analysis, to implement the green options that can bring it in line with other implemented the fringe options, the medium term, could improve it significantly. And if not the whole hog, ultimately, and make strategic changes too, they're more than halving the emissions of the building. Just then, we've got lots of things out there. We're looking at and renovation and prolonging the service life of buildings. I happen to believe that's preferable if it can be done to knock into a building and starting again. Generally, a poor understanding, even within our industry, I would hold my hand up there about the performance of buildings and why they perform in a certain way. And there's lots of very good research going on into building physics. But to the person, I think we've often seen struggling or having conflicting information about the best way to improve a building. Traditional approach is good, but tends to from time scales. So consultant might want to be in a building monitoring energy performance for 7 months before he wants to make a sort of observation on what's happening. And really, the imperatives are there to now to deliver cost savings and improve performance. So using REM, we can deliver some and useful insight at an early stage and at relatively low cost. A wider management tool, REM's the first step really for us, and what we're putting on all projects with is a program called energy asset management or energy contracting, or there are several. It basically means look building long term. So instead of producing a one-off piece of consultancy and saying, there's a report that tells you energy saved by making these changes, and then walk away, our job's done. Energy asset management is a longer-term view on things. So actually sticking around holders as partners, have swallow the management operation of a building in order to reduce to guarantee reductions in energy and carbon emissions long term. So we've got a strong work group on this opportunity, and REM for us is really the first step. It's what we would need to do to assess building and to decide for ourselves and for the client what the potential to improve it. So I probably talked for long enough, and I can see there's some questions coming in. I will look at those now. I think that's the last slide anyway.
Thanks a lot for that, Oliver. A really good overview there of what REM is all about and how it's being put into practice. So we'll go on to the question and answer session. We've had lots of questions come in, so we'll get through as many as we can in the next sort of 10 to 15 minutes. So a good one, I think, to kind of kick off with is here, which is the benefit of this methodology compared to undergoing an EPC and a CIBSE TM22 energy survey, which are kind of the recognised standard which is used conventionally. So, Oliver, you've got some thoughts around that?
Sure. Yeah, I have. I mean, all of us, what I'll say first off is that it's not independent to an EPC. So we could use an EPC at the same time as undertaking this, and a lot of the information that we gather is there's overlap there. But an EC really, we share on this, is a compliance and recognised course for assessing criteria under Part L, and in that sense, it's of limited use to you in actually understanding how to improve the building operationally. In my mind, there's an analogy which is probably not a very good one, but it came the other day, is that an EC is like taking your car in for an MOT. So the guy will perform a series of checks and tell you whether the car passes or not, and that's a building. But then, if you was going to service over the next year or 5 years, then in their own terms, they need to perform more detailed check and so on. And I would say that rapid energy modelling is the equivalent. It's actually going into much more detail about the so just looking at regulated energy and not within the constraints of Bell's criteria, but it's actually looking at the building as it stands, as it sits there, and the evidence, using the evidence that we can gather about the building to make real operating improvements. And what TM22 strives to do as well, but say that TM22 lacks the political advantage that we have. So, using the rapid energy model, we get an extra insight into how consumed in the building. So, just going back to that example I said before of the identifying the high solar gain in our Basingstoke office and the fact that was causing a lot of cooling energy to be used. There are many insights, some of them much more subtle and less obvious, that cover our rapid energy modelling approach that TM22, neither TM22 nor an EPC would be able to reveal.
Great, Oliver. I mean, quite a nice sort of follow-on question to that that someone sent in is, what other uses could the BIM model be put to, and has ownership of that model? Because presumably, if you're carrying out the survey and building the model, do you own it effectively?
Well, the grey area there. So I can't give a definitive answer because I haven't come across the situation yet where we've generated a BIM model and then there's been discussion with about ownership. So far, all the models we've produced sit with us. But now that's not to say that we would have a problem in the future or sharing information. I think quite the opposite, really. If the idea of BIM is that the information should be shown available to all. But an example is the daylighting that I showed earlier. We created a model to perform energy simulation, but used it for a daylighting study. And those are different things, but they're related. Example is we've just come onto one project where the architectural BIM model is available. So it built where a full architectural BIM model has been created. Now created with the intention of any modelling. It was created to allow the architect to design his building, allow the cubes to pull off costs. So each element has in the BIM model has a cost associated with it and a construction phasing and so on. We can draw that BIM model straight into our energy software, and with a checks and balances, perform the energy simulation. So we benefit already of BIM in this context.
Oliver, I mean, following to the BIM model and how you go about creating it, someone's asking, do laser scanning and photogrammetry only give you the external geometry? And in case, how is the internal geometry added into the model? And another sort of similar question is asking, are there issues if your building is part of a terrace rather than a freestanding building, as we did in some of the examples?
Yeah, they're good questions. The key point to make is we focus on what the intent of the model will be. Now, if we've got a good chance that the model that we're creating will go on to become a BIM model, then we would use the laser scanning, for instance, to capture internal as well as external geometry, and we can put the laser scanner inside as well as outside. The ways as well, I mean, handheld laser devices and all sorts of things that we can use to get hold of internal geometry and feed it into a model. However, obviously, the cost of producing the model and the cost of processing the model increase. Now, if we use that model for a level energy survey, which is essentially what REM is, I mean, it does give us a simulated a simulation of energy content. But it might be simulation at that level until you go down into the very nuts and bolts of very detailed building physics. It is regarded as an indication of the performance context. We probably would get without feeding the geometry of the building inside. Now, I'm not saying that we would leave it as an empty box. Far from it. We put laws in, and we put these zones in. So, we divide up, for instance, cores, lift cores, toilet cores, and key zones that were heated independently and cooled independently and occupied differently. We don't need to use a laser scanner to feed that in. You can do that from drawings or by sort of rough estimation. The discussion we'd have with the client really is as much time to invest at the head end for in the model. Great,
thanks a lot for that. So we've now got a couple of nitty-gritty techie questions. One is it all based on SBEM software, or if not, what is the energy analysis software that's used?
Not based on SBEM. We do run SBEM. SBEM's a fairly blunt tool in the sense that it can be used for assessment and much else, but the other bits of software that are also approved and can be used EPCs like IES and TAS, and we use those, but we don't exclusively use those. We also use other tools like Autodesk, for instance, conceptual energy analysis software built into their BIM modelling. We use a variety of tools, and they're all to checking and comparison. In fact, at the moment, we tend to run two simulations for each building, and to ensure that we've got that are within range, because there are different energy models out there. The desk one uses a S-based modelling engine, and ICE uses the N as SBEM, the national calculation methodology, but it's a slightly more detailed and powerful tool. But in that, we also add in our own filters and our own analysis, because we understand from many of actually going to buildings as well as modelling buildings that you can't capture everything within a building simulation. So we actually we modify the information as using our own algorithms.
Thanks, Oliver. Next question here. It kind of picks up on the case study which you ran through and the sort of low, medium strategic recommendations. They're saying there's no mention of submetering or smart meters. Is this as it's too costly? Obviously, it provides better levels of calibration over time. But does CapEx outweigh the benefits?
And smart meters were one of the things identified in that list of good practice measures that I talked about. So I didn't schedule them out independently. Now, the difficulty is with is that submetering is something I recommend in almost all cases, because it allows a greater level of information capture, and you can't manage what you can't measure, is the old maxim, and we believe in that. However, it's difficult to quantify the actual benefits down the line from submetering, because it all depends on what you had there in the first place. So if metering allows you to uncover a significant problem you didn't know you had, a significant benefit from it. If metering just tells you that everything was hunky-dory, and that's all to know, and you may not get so much benefit. So it's very hard to give a generalized answer as to what's the benefit of submetering, but we recommend it as a matter of course. It allows more powerful and accurate analysis in the future, and if we're entering into a longer term agreement where we're responsible in part for energy performance, or we're bound into some relation to energy performance, we would specify submetering as a matter of course. Great,
thanks. Another question we've got here: how do you calculate the operational rating to calculate paybacks based on your recommendations? There was another slightly related question also, which was, where do you get your financial data from to start building the business case? And could you use could a company use some of its own data also? I guess if they've got special deals on certain things.
Yeah, good questions. So the operational savings, I'm not clear in the presentation about our methodology, but we'll run the rapid energy model base case, and we've identified a series of improvement options. We then modify the model and run a series of improved scenarios. So that we get the operational saving, because the new scenario will indicate a reduction in, let's say, lighting power, and we'll use that information. But then there's the cost of making that change to improve the lighting, and that's more because we're not consultants ourselves, but we have a whole database for assessments. So it depends on kind of what level of detail we want to go. But for an early stage, we would use a database. It's not a database. It's bits taken from RICS. It's bits taken from the the British Council of Offices. It's bits taken from SONs and lots of bits taken from our own experience. I mean, we do as M&E engineers, we specify improvement changes to buildings, and we have a log of what those kind of things cost. So at a more advanced stage, perhaps as we're moving into considering implementation and really narrowing down a list of options, we would use a cost consultant partner, or we would use the client's cost consultant or the client's information to bolster those calculations and refine them.
Thanks, Oliver. So I'm conscious of time, but I think we've probably got enough for a couple more questions. We've got a couple of fairly short ones. One is, have you ever done REM at a school, on the school building?
The answer is no, we haven't yet. We would like to. So we're very open for a discussion with the question there. We haven't done some student accommodation, but we haven't a school yet. I don't anticipate any problem with doing that, and it will be an interesting project. Certainly something that we're looking at a few opportunities in schools at the moment.
Great. The one, I know this is a bit how long is a string, but someone was asking, how long does it take to carry out one of these surveys? Can you give maybe just sort of an indication compared to a more traditional approach, maybe?
Yeah. Sure. Okay, so a couple of weeks ago, where the opportunity, various reasons, the window of opportunity to actually go and look at a building was very short, and able to, we were notified one day. We visited the site, and I'm in London. This was in Middlesbrough, so but we're a nationwide team, so we're able to mobilise someone, and within the days we had a model up and we're printing our findings by the end of the week. Now, a perhaps slightly accelerated program than we'd like. Typically, a single building, a couple of weeks would be good to, provided we can get in there and perform our survey and present of our findings and discussion and so on. With more portfolio-based work, actually, one of the great benefits we see with this tool is its scalability. So we're looking at a portfolio. There's one particular unit at the moment where there are 50 buildings, and we've allowed 4 weeks there to those and produce the buildings for that building. So that's an indication, I think.
Great, thanks. Another quick question: can this modelling be performed on other types, such as shopping centres, that sometimes have non-regular shapes in comparison with office buildings?
Yeah, we do like a challenge. So I would say yes. We did a very unusual building over in Bremen, over at the Beck's Brewery. We've got a octagonal story tower there that was. That is still a regular geometric shape, but yeah, we can do that.
Brilliant. And just one final question now: how can you account for occupant behaviour?
It's one area of simulation which often leaves something to be desired, but we account for it in the same way that most simulation tools would account for it, in that we have access to a range of predefined profiles for different occupancy types. So right the range from residential to hospital to office to commercial and retail and all the things in between. And there are many variations, and each one would set a profile for an average density of people in that kind of scenario. So how many people per meter squared, or how many meters squared per person. What activity they would be performing. In other words, are they sort of sedate? Are they sitting down? Are they moving around? And how much heat are they giving off? Ventilation rates. The usual operating hours of such a building. And we would model that with what we've actually observed. And we can do that within a building. That's another point, is that we don't have to say, right, this building is a school. We could say, well, part of it's operating as a school, but this part is actually the assembly hall. So that's used more sporadically with less people. And then we can also modify those characteristics with what we've seen. So if we see, actually, it's not just an office, it's an intensively serviced call centre with people that are sitting much closer together than in an office, we would modify those profiles accordingly.
That's cool. Thank you very much, Oliver. That's all we've got time for today, but I'd like to thank Oliver for his time and for getting through so many questions, and also for everyone who joined us for this webinar. Just to remind you, a recording of the webinar and the presentation slides will be archived on the 2 Degrees platform, and for those questions we didn't get time to answer, we'll post up in a forum for further discussion. So I hope you found today informative and useful, and that you'll be able to join us throughout July for our ongoing programme of webinars. So thank you.